Hello. Today we will be discussing the assembly of the Analog Discovery 2 Digilant Oscilloscope. The goals of today will be discussing the assembly of the oscilloscope and wave generator, specifically including the BNC breakout board, as well as the T-shaped board, and how to put it all together using a breadboard. Additionally, we will be generating a simple function to test how it works and show how each of the probes interact. To begin the assembly of the Analog Discovery 2, we will first take the actual oscilloscope and the BNC breakout board. Here you can see male pins on the oscilloscope, and you will plug in the female pins on the BNC breakout board such that both of them are facing upright, as seen here. Next, we'll take a look at the BNC breakout board. You'll see a number of probe connections labeled W1, W2, CH1, and CH2. These are for the waveform generators and the oscilloscopes. There's a jumper attached to each of these. For the waveform generator, what you will do is take that jumper off of the JP4 pins and simply attach it such that it is hanging off of one of the two side pins without connecting to the middle pin. We will come back to this later in order to utilize the wave function generator without needing to use a BNC probe. You can also use the jumpers for the oscilloscope channels to change the coupling from AC coupling to DC coupling, which will either allow for you to see the DC offset if it is in DC mode, or it will ignore it if it is in AC mode. Your choice for this depends on what you're specifically looking for with your oscilloscope. I will now be attaching a BNC probe to the oscilloscope channels. First, you will see a little knob on the top of the breakout board probe attachments. You will slide this into a slot on the BNC probe, and then twist the probe such that it snaps into a little hole that is there for it to be in. You can see it happening a second time here. The next connection we will be making will be to the T-shaped board and the breadboard. So first, you will take the male pins and attach them to a female-female ribbon connector. Before we attach the other side of the ribbon connector to the T-shaped board, let's bring out the breadboard. To attach the T-shaped board, take the pins that are on the bottom of it and place them 2 away from the central divider. Generally, it's easiest to have this T-shaped board at one end of the breadboard, and having them 2 away from the divider makes it evenly spaced. Press it in to ensure that all the connections are made. In order to connect the BNC breakout board to the T-shaped board, first you will need to connect the 15x2 male-to-male adapter seen here to the T-shaped board. Simply fit one side of the pins into the T-shaped board and press in. Once that has been connected, you'll be able to connect the ribbon connector from the BNC breakout board to the T-shaped board. First, check that the ribbon connector is not twisted in any way. You can check by making sure that the wires on each side maintain on that same side throughout. Then attach by simply pushing in the pins from the female connections to the male connections as shown. In order to get the waveform generator to work, we will need to use a male-female jumper cable as shown here. First, we'll plug the male end into the W1, that is where the waveform generator signal is supposed to go to. With the female end of the jumper, we will plug it into the center pin of the JP4 set of pins on the BNC breakout board that we exposed earlier. This will bypass using the probe connection in order to send the waveform generator directly to where it is supposed to be on the board. This is a workaround due to the fact that the signal does not travel straight through the BNC breakout board and only goes straight to the probe connection. This will allow us to connect to waveforms without requiring an extra probe, which is not traditionally used for a waveform generator. We will now begin testing to see if all the pins are correctly attached and checking the functionality of the oscilloscope. In order to do this, what we will be doing is starting up the waveform software on our computer. The other thing we will be doing is plugging in the Discovery 2 using the micro USB on the back of it, as shown here. Once Waveforms has connected successfully to the Discovery 2, it will show in the bottom right here. You want to open the oscilloscope by pressing Scope, as well as opening up the wave generator with WaveGen. This will give access to the controls for the oscilloscope and wave generator. In order to determine what the wave function generator is actually outputting, you will need to put a stub along the line of the breadboard connected to the wave generator. Keep in mind that horizontal lines, in this case the one labeled 5, are all connected to each other on a breadboard. We also need a ground connection for our measurements, so we insert a wire into the breadboard where the T connector shows the ground symbol, which is the arrow pointing downwards. You can see that here. Next, we will be attaching the oscilloscope probe in order to determine what the waveform generator is producing. So first, attach the probe to the stub coming out of the wave function generator's node, and then use the alligator clip attached to the probe to connect to the ground terminal. This will then connect the oscilloscope to the waveform generator, so as long as both are on, they should be showing the same results. You may turn on the oscilloscope and see that while there is a little bit of noise, it is mostly flat, and then as soon as you turn on the waveform generator, you see the waveform that is being produced in the oscilloscope. And as I change the waveform generator, the oscilloscope changes to match. This shows that the connection of the waveform generator is working, and the oscilloscope is connecting directly to the waveform generator. Thank you for watching. I hope this helped for setting up your Digilent Discovery 2.